Hey everyone, let me get started. I'm not going to read the title to you. For some reason, I picked the longest title that I could imagine. Maybe path related. Anyway, for the people that don't know me, I'll quickly introduce myself. I'm Olaf. I'm from the Netherlands. I'm a detection engineer at Falcon Force, company I also partially founded. I've been in the blue space like forever. I've never done attacks. I replicated attacks and I tried to understand them in order to properly defend companies. But that's about it. You don't want to have me as a red team operator for sure. I didn't study any cyber stuff. I used to be a documentary photographer. I went to art school. So I'm fairly visually oriented. That's why I like graphs so much, I guess. And of course I like warm hugs because every Olaf does. So what can you expect from me today? So we'll have a lot of slides with lists. I'll use some graphs to talk about the value of lists. Some more lists because I love lists. And of course we're going to talk about how to apply BloodHound stuff for blue. And the reason why I made the list jokes, it might be obvious now. This is a quote from John Lambert from a very long time ago, where defenders seem to think in lists and attackers don't. But as long as that's true, attacker might win. Not fully agree with it, probably, but that's fine. It bugged me and I wanted to do something about it. So a year after that at Black Hat, they released BloodHound 1.0. Like baby BloodHound, the graph was tiny, but already useful. And by now, I think it's even grown more. This is an old screenshot from Andy from I think a year ago, where you can see the graph has like exponentially grown. And the value for most of the offensive people is obvious, right? It's been used quite a long time and it's extremely powerful, extremely useful. And sadly, I don't see a lot of people on the defensive side utilize it as much as they could. Right? Quite often we see them run it once a year on an assessment or an audit, go through it, fix stuff, good. And then next year they do it again. But in the year in between, it's like gone, which is a shame. And it's not necessarily the lack of documentation. There's plenty of stuff around like red team pen testing stuff. But even if you Google with the blue team force quotes in there, you get plenty of results. It's not all blue team focused, of course. But we are all creative people, so we can think about how we can actually apply it and how we can use it. So talking to a lot of blue teamers, of course, fake tweets, but there's a lot of sense of, hey, this isn't built for us, so why can we use that? Or, yeah, I'm not really familiar with Cypher. It looks like a very daunting query language, and it has a learning curve like any other ones, but you'll get used to it. And then the next thing is, so I can't keep on auditing this because I'm busy running incidents, these kinds of things. So how can I utilize this in a more sustainable manner? And then for both sides, there's quite a lot of challenges in collecting data in the first place, right? You need to run scans and you need to schedule that. Usually you need to get permission from somebody. Sometimes other operation teams or network people won't like you because you want to have the firewall opened up to all the networks. And that's also sort of the next point where it's pretty hard to penetrate like all of your subnets if you properly segmented your network, because then there's all kinds of firewalls in between and boundaries to get like session data and local admin data, that kind of stuff. And the biggest downside of running a scan is like once you're done, it's already sort of old. And you don't run it consecutively because, reasons. It's quite a lot of work, it's quite compute intensive, and then you also need to ingest like this huge amount of data every time. And then of course, the same thing is all your local data isn't as visible as you want it to be maybe on the AD side. And then the next question comes to rise is like, hey, I scanned this session yesterday, what about now? Do I scan again? These kinds of reasons. So that's still a struggle. So yeah, maybe an obvious point is, but why are sessions important? So let's imagine this user, he has a session to this computer, but there's also this like diamond user, which is usually a global admin or in this case a domain admin, that had a session to that computer as well. And they also had a session to a domain app or domain controller. So in this case, it was had a session, and that's sort of maybe a precursor to later, which is one of the edges I added, is it's equally valuable. So even if the user isn't logged onto that machine right now, it's quite likely that they will return, right? If somebody logs onto a machine, they probably do it again. So an attacker can wait for that, capture the creds, and play with it. Or maybe the creds are still stored in memory. If the session is very long, it might be still present. So all this information is something that I figured as a blue teamer, it's like, hey, we kind of have this stuff, right? We have logs, and logs are boring for some people, but they're extremely powerful and useful to me because I can see who logs in where, when they log off, and where else they are playing around and doing all kinds of other things. So with that, we can do a lot of cool stuff. One of the things, again, as I mentioned many times now, we can see logons, but also unlocks, we can see logoffs, we can see if a user is modified, if a user is added to a group, if there's a new group created and then a user has been added to it, all this kind of stuff. But we can also, since we are looking at logs, we can generate alerts. Our EDR generates alerts, all these things that generate alerts, which also might open up some new attack potential or give us the capability to track an attacker along a path. And then on the Azure side, we can also do all kinds of other tool stuff like role modifications, but also the eligibility of a role, which is a PIM thing on the Azure side. And one of the other things that I'll demo later is also MFA. So if somebody hijacks your MFA, suddenly they have control over maybe multiple accounts. And all this stuff, again, is logged, so it's in near real time. Depends a little bit on your platform. Azure might be sometimes a little bit slow in logging, but still you'll get it. And every time you process this, your path might change. So this is why we created FalconHound. The first version was created by JD in the back in PowerShell. From there, we learned that if you used, or at least I learned with limited PowerShell knowledge, that if you run that at scale, it struggles a little bit with big data sets. So at some point, we converted it to Go, which it has the ability to query like all these data sources. I'm not going to list them out, but the primary one is probably Neo4j for BloodHound. And I support most of the bigger logging facilities. So it queries the data, and then it stores the results somewhere else. So one of the things could be I query a log and I store it in Neo4j, and I can then do path calculations, but I might also want to query Neo4j, be it BloodHound, and get it from, give me all the domain admins, and put it in a watch list for my SIM to actually work with, which should be always up to date instead of generating it from AD and then doing all kinds of other hassles, right? We have one single source of truth already. And since it's built in Go, we can build it for Linux, for Windows, for Mac, whichever you like. So you can put it next to your BloodHound Docker instances or whichever you're using, which is quite convenient. So basically the only thing you really need to do to start using it is create API credentials, configure them, decide on, well, put it in a config, of course, define basically what you want to run. So which platforms do I want to support and what queries do I want to execute. There's a long repo already with stuff in there. And then you basically create a cron job or schedule task to run it every whatever you like. Generally, I'd like to do it every 15 minutes because some of the path calculation queries can take a little. And you don't necessarily need every 5 minutes up-to-date information in most environments, unless you are so heavily automated that you can actually stop an attacker within 10 minutes, which would be impressive and rare, but I give you the challenge. So basically, the simplified flow of the whole tool is we have a lot of actions that it can do, one of which is it queries logs. It will process the results, make it into a nice JSON format, and then it can either upload it to Neo4j or to a CSV file, watch list, markdown file, whatever you like. Then there is a bunch of cleanup actions that I do. So one of the things is I time out sessions after a certain period, but also if I remove closed alerts from an object. So let's say I have an alert on a user, which I wrote down first, then I resolve the alert, then I also want to remove it, because then that user isn't owned anymore in my world. So I want to clean that up. And then I have a new clean database in Neo4j, then I query it for all kinds of paths, all kinds of information that I want. I process it again, and I basically write it to either my sim or a watch list or a report or whatever we like to do. It's all supported there. The markdown is limited, right? So it's basically just giving you a table of all the results that you were interested in, but it can be very useful to copy paste that into your report. So some sample actions that are in there. So one, of course, as I mentioned a lot, is keep the session information up to date, which is really useful in terms of like, hey, how are people moving around my network, these kinds of things. But also marking everything that has an alert on it as owned. And of course, owned is potentially owned because we have false positives in the blue team world and all kinds of things. But still in correlation, that might actually be interesting or prioritize the analysis of your alerts. If you know, hey, this user has a path to a sensitive resource or something I care about, and there's an alert on it, I might want to investigate that before I look at that other user that doesn't seem to have any access. So that can already be a very nice thing to reprioritize your flows. And basically, because we're repeatedly querying for all these paths, we can do all kinds of interesting bits where we can see lateral movement activities and these kinds of things throughout our environments, but we can also add new users, new groups, everything that is added to your environment in between your bigger scans, which you still want to do. We can keep it up to date in the meantime, right? And then we can augment it whenever we import a new scan. And we could even start calculating choke points and other paths that might be more significant than others. But you have to build those yourself because I don't want to butcher the BHE product. But technically it would be possible, even though the capability is probably limited and I'm not as smart as all the developers out there. So how do you configure this? So basically there is a YAML template that I provide for every action. And of course this is way too little to read, but technically you basically give it a name, an identifier, some other metadata, whether it's active or not, and whether you want to debug it or not. And then in there you basically give it a source platform. So what do I query? So in this case it's MDE, Defender for Endpoint. And I give it a native Kusto query. So I basically just tell it, hey, fetch this and project only the stuff I care about. So it's sort of get data. It's not, yeah, if you know Kusto, this is very familiar. If you know Splunk, you write a Splunk query. That's sort of the thing. And then you define outputs. So I call it targets. And you can have as many as you like, as long as it's supported by the code. But in this case, it's a Neo4j target, and it's a watch list, so which is the Sentinel equivalent of the Splunk lookup list. So it's technically just a CSV hosted in the SIM. And again, on the Neo4j side, you just give it cipher. I try to make it as simple as possible, but technically I work with the Neo4j parameters. So for every result from the top query, I generate a cipher query with the parameters that I care about. So in this case, I have this fancy thing, right? Does it work? No. Okay, great. Technology. So basically, I replace this $sign device name with the device name that I get from there. And I do that with all the other ones. So you can technically just juggle with data and get it into the right format, and it will take care of the submission for you. So if you haven't imagined ideas, some practical use cases that you could think of is generate watch lists for devices that are harder to mitigate. So you'll have some paths in your environment, right? You can't get rid of some are just needed. So you can put them in a list and maybe deprioritize incidents or reprioritize incidents if one of those resources is involved. But you can also generate, basically, well, in Kusto it's very easy. I'm not sure about Splunk, but you can basically do a diff between the previous set of paths and the current set of paths, because I write them every time. If there's a new one or if one grows, I want to have an alert. I don't care about the same paths that I already knew about, because that's just flooding people with alerts that they can't do anything about. And one of the other cool things is you can track uncommon session or anomalous sessions along a certain path as a sort of lateral movement indicators. Like, hey, this user never logs into these kinds of machines or shouldn't. If it happens, I want to have an alert. So there's one action in there that automatically looks for domain admins that are logging into workstations, for instance, right? Why would they? There's simply no reason for that. So these simple things you can also build as an action, but you can also do that within your sim. And you can also uncover risky resources that have paths that you weren't aware of, which I'll have a couple of examples for you in a sec. So of course now I try to do a demo if the internet permits me. So if you don't give it any permission or any variables, you just get the help output. And there's a couple of things you want to do. So if you want to use Azure Data Explorer, you need to initialize it. If you want to use Azure Key Vault, there is a variable that you can give it as well, and it will get all the credentials it needs from an Azure Key Vault. And you can also play for debugging. There's a couple of options that you can use. So let's see if this is actually readable. Hope it is. Yay for dark mode. So one of the things that you can do if you are running on the that's too much. So you can basically also look, if you don't want to read through all the documents, but you can get a list of all the actions that are there. So these are currently, there's 68 actions that it can take. So this is already out of the box provided, and contributions are very welcome because it's more of a pet project. So basically you can see where it's running. So if you don't have Elastic, then disable it. There's also a feature in there that if you don't provide it creds for Elastic, it will try to run it and see, hey, there's no creds, and skips it. So you don't even need to tamper with it that much. There's two variants of the Graph API in there, which might be confusing, but there's the Go SDK version that I use for certain things because they're quite complicated with consecutive lookups. One of the ones is the, where are you? Well, anyway, I do MFA lookups, but you have to do that per user. So you have to basically get all the users and iterate over all the users to actually get their MFA settings from the Graph API, which is extremely useful. But yeah, you can't do that with a single URL-based query. So the MS Graph allows you to just give it a graph URL, as you would also do it with a curl command. And if you want to do fancy stuff, then you have to build a Go module. So that's the same with OAuth consent and some of the other things I've added recently. The rest should be very straightforward native query languages for Sentinel, Defender, or Cypher. So one of the things that we can do now is just have it run. You have to. It assumes a config local. If you have multiple configs like I do, you can basically define where it actually is, and then you set it off, right? So it starts querying Sentinel. If it finds stuff, it will tell you what it's doing. So in this case, it's finding not much because it's one of my lab environments that is relatively stale. So I'll board that. And basically what you can also do is if I'm only caring about, for instance, these sessions, I can actually tell it I only want to run, for instance, this query. And then I can just run that. It actually finds 2 sessions. But let's say I haven't run it in a while because I ran it on my laptop and I was traveling and had these kinds of things. I can also give it a bigger look back and it will override the default of 15 minutes. And now it actually found 11, right? So it will update Neo4j for us, do all that kind of fancy stuff. And if I'm not sure if it's actually correct, I can give it a debug. And it will also give me like all the raw output. So it will give me the JSON that I get back from, in this case, Sentinel, with all the query results. So I can see there's all kinds of stuff in there. And then all the consecutive Cypher queries that it's actually generating and updating my database with. So you can see that I set a source, in this case FalconHound, so I can also query like how many sessions are in my database that I generated compared to what is automatically imported. If you care about that stuff, it was primarily useful for development purposes, but I left it in there just to have a stamp in your environment. And then here you can see that basically I'm doing a merge of a user and a computer with a session, right? So that's one of the things that it can do. And then, of course, on the other side, it is equally interesting. So before I forget stuff. Yeah, and basically what other things is doing, what I actually wanted to show, but I copy-pasted another one, is Defender for Endpoint also logs CVEs on the machine because they run Qualys Lite on it. And they also flag it with a tag that says, is there a publicly known exploit for it? So I built a query that looks for only hosts that have a CVE and a publicly known exploit. So technically it might be exploitable. So one of the things that we can then do is flag that back to Neo4j. And the same, what they also do in Defender for Endpoint is they look for machines that are publicly exposed. So how they do that is interesting. They host it, I think on DigitalOcean, they have a box that is continuously scanning the whole internet for ports. All those results they are storing, and they're correlating on the back end. So Defender for Endpoint also looks for incoming connections, right? And if there's a match, then it's a publicly exposed port. And the reason why they do it from DigitalOcean, like all attackers also do, but basically there's a lot of people that are whitelisting or allow listing the Azure IP space because they also use it for that same reason, and sometimes they do that kind of stuff. So if they scan it from their own environment, that might give a lot of false positives, whereas if DigitalOcean can reach it, bad guys can reach it too, so it's more relevant for you. So one of the things that I add there is also that flag. So I've basically given an exposed is true flag if there is something open on the internet. So if we look at it, we can actually see that this machine is actually also exploitable apparently, but it's exposed. And then we can even, it's exposed since the 9th, so 2 days ago. And the ports are 3389, so right? So in this case, RDP is open to the internet for this machine, which I still don't know if that's a problem. I can maybe look at if, oh, it actually has some outbound object control, but this is Jonas's talk, so I'm not gonna look into that bit. But another one is, I can have a look at like, hey, who has logged on to this machine, right? So since I'm syncing everything, I can see that 3 users have been, are logged on to this machine. So that might be already more interesting in this case. There's a sort of spoiler because you also see diamonds since it's a tiny lab. But this could be an initial access vector for a user, right? They can password spray either one of those 3 accounts. And basically then we can go into the little bit fancier cipher. We can actually see what would happen if this machine got compromised. There's quite a lot that they can access, right? So this is like half my domain. So this is actually the query that would run through FalconHound, and that output, all these paths are basically sent to Sentinel. So in Sentinel, we get information like, first of all, like these exposed device to high values. So this is an event ID that I generate, and every time I run, if there are results, you get a log entry. It might be hard to read. Let me see if I can expand it a bit. Is that better? And I give quite a lot of information. So what I also do is I add a query that the analyst could copy paste into BloodHound and see what am I looking at, right? If this, I also give it as a list because Sentinel can't show you graphs and we need lists. So it will give you a list of all the stuff that can be accessed. So this is not good, technically. So there's basically, they can get to anything, which you don't want to have. So if you can't parse this, then you can also just copy paste that same query that I actually just showed you in the UI. You can just copy paste that. So that's sort of a very basic demo of one of the capabilities. And then going back to slides, because I'm kind of behind already. And this scales quite well. So this is a screenshot of me running it at a 150,000 endpoint environment with 200,000 users and 80,000 servers. And it's probably not legible. It will eat some memory. In this case, it's like 50 gigs. That's primarily Neo4j, being very hungry, being Java-based, which everybody not likes so much. So anyway, to really give it a spurs, I also figured let's collect all the sessions in that environment of the last 2 weeks, which you'll never do. But I wanted to see the performance of the tool. So it got 340,000 sessions, and it took in maybe 2.5 minutes. So what is it? 3.5 minutes to get that into Neo4j, which is pretty cool because in the previous version of the tool it took 15 minutes. So, but basically what it's doing is it's looking up every user and then every computer and then making the connection, right? So it has to do quite some transactions. And this is on a fairly stock server. It's not on my laptop because that would take definitely longer. So yeah, in most environments this would work, even with Neo4j. Some stuff just to show you basically how it looks on the back end. It's the same. So we're looking at Neo4j where I'm sort of doing a similar query of a session that I showed you earlier, and then you can see like how it would generate that hash session tag. The cool thing about Defender for Endpoint is that we can also collect that, but also on the Sentinel side, we can collect logouts, but not everybody logs that because it's also noise. So one of the things that I also do is I time them out, and that's configurable. I do it after 3 days. I assume most sessions are dead, and otherwise there's probably some activity again after the weekend, and it will get a new update. But I don't delete the session. I replace it with, so from the has session to a had session, so a former session, and I record when I timed it out. And this is particularly useful since I'm also generating alerts for an analyst. And if they copy paste that query that I showed you earlier into the graph, and it's like, hey, I don't see it, it's gone because I removed the session. But technically the problem is still there, right? So we can't analyze it properly. So that's why I introduced this, and also because it's quite likely that the user will be back. So that path is actually very relevant. So that's one of the reasons why I started adding these kinds of things. So I keep on extending the schema, and maybe in hindsight I might redesign some bits. But I have like a had session property or edge that I introduced, a has consent, so OAuth consent. So I'm not sure if you were in the SaaS-based path attacks this morning. OAuth consent is extremely well used by attackers, sadly. And we can see the scopes and everything from the logs again and from the graph API. So we can again update our graph so that we can see what the attack paths on the Azure side at least are. And one of the other bits that I started playing with is, since I saw a lot of clients getting account hijacking where they would do some man in the middle or adversary in the middle attack, add a second factor to the MFA, like a backup one. So even if you use the device authenticator thing from Microsoft, they might add a phone number or an email address that say, hey, I don't have my phone right now, but I can access my email, and they can still log in. So that's a very useful one. And I have some examples that it actually worked as well. And one of the things I was missing as well on the Azure side is the roles are collected, but the eligibility, so like the privileged identity management component, where you technically don't have the role, but you can assign yourself the role, which is for an attacker the same thing. I also started adding that. And on top of that, there's all kinds of properties. It's way more than is on the screen. But all kinds of additional information, like the publicly known ports, but also the CVEs and these kinds of things. So how can we use this as defenders, which is probably the most important bit, is a couple of things. So one of the things is you could start building queries like this, or copy paste it from the slide, where I'm looking at a deviation of paths. So I know what I have now in terms of paths, which I might have investigated or can't do anything about. But if it grows, I want to know about it. So that's basically what this query does, right? So if there are new paths or new steps in a path, I'll be informed. And the way that looks from a practical side is, in this case, this is from a real client, still on the old BloodHound, but it doesn't really matter, where that user on the left was compromised via a silly phishing attack. But I mean, it's a long path that the attacker has to take, but it's just adding itself to certain groups and logging into the machine, and then all of a sudden, they own the whole company, right? So it might be lengthy, but it's relevant, and it's actually happening quite a bit. And the same for one of those other scenarios is where this is on the bottom, there's an SCCM server with a fairly old SQL version on it, which has RCE. And from there, it isn't that far to a full domain compromise if they wouldn't abuse the SCCM in the first place, which is also very feasible, as we saw earlier today. So not necessarily that the defender can do something about this, but for one of our clients, we're now also connecting it to their vulnerability management system and their team, and they are actually using this now as one of the inputs of prioritization of patching. And it might not be possible, but they can isolate the host maybe a little bit more, something like that. I mean, a user doesn't necessarily have to have access to SQL directly, these kinds of things, so they can do stuff about it at least. So it might scope broader than just the SOC. And you can do way more, right? So you know the Kerberos users because you can collect them from BloodHound like every user with an SPN. So if for some reason, this is the poorest lateral movement example ever, but that user starts getting a session somewhere, we can do two things. So we can generate a watch list, which we can correlate with our event logs and generate an alert that way, which is probably the most likely way a SOC would do it. Or you can still use BloodHound as well, or the Neo4j database, run an action where you can actually see, hey, I updated the session for a user. That user also has an SPN, so I'm writing a log entry. Or do both, right? So you can have multiple options that way as well. I showed you this where the query is usually also pasted in the SIM, so you can dynamically do stuff. Or take it a little bit further where we're designing our own investigation, enrichment, and analysis platform because we didn't like what was out there, like everybody with open source also does, right? Why not another tool? And basically what we're doing is we're getting every alert from our environment, getting all of the entities out, so IPs, email addresses, whatever, and we're running all kinds of enrichers on top of it. And we can provide additional context like how many other alerts have been triggering in the environment, that kind of stuff. But, and this is an older version, but still relevant, we can also check already some relevant stuff. So how many outbound things can that user control? And we can even just with a small fork of the Docker container, we can also just implement it in the tool. So now this is a screenshot, but we now have a live version where the analyst already has the query ran that was in the log, and it can immediately visualize it as well instead of scrolling through a long list. So that's actually quite useful. And then another cool thing is we can actually see lateral movement as well. Well, technically we could, right? At least the likelihood of false positive, the likelihood of lateral movement is there if you know a path and there are more alerts popping up along a path. We may be able to investigate that user now because he hasn't generated an alert yet, but we have to assume that the attacker is looking at the same data as we are, even though we might have a richer set with all our enrichments. But we can now take steps as well. We might be able to block this user or isolate that machine so that the attacker at least can't progress while we are also investigating that stuff. So we can be a little bit more proactive. That's kind of cool about it. The sad thing is that BHE doesn't really have that owned indicator yet. So that's why the screenshot is from the old interface. But I mean, you can query it, so you can also just or fork and add it yourself. Technically, also not that hard. But maybe feature requests, Justin. Yeah, and then some real world stuff as well. Yeah, it's been mentioned a couple of times today, so I won't go into most of it. And if you haven't read about it or heard about it, this video is epic. You have to watch that. So I tried actually recreating that attack, which even the fault that Microsoft introduced into their own environment is pretty hard to replicate. To get a enterprise app registration that is from a former tenant and then trusted in the second tenant and able to do stuff, creating that is already not trivial, at least not for me. It took me quite a bit and it's not documented, so you have to fiddle with the Graph API because there's no UI that allows you to do it. But basically, this is sort of a visual representation of how that initial vector looks, right? And now we know a little bit more from the blog post from a couple of days ago that most likely password spraying was the initial access vector. No surprise there. Apparently, they didn't use MFA or not proper one. So it was relatively easy to get into that dev environment. And from there, they could laterally move along the path. So one of the things, again, is what I collect all of the MFA information. So I can see that this user has phone and email as their authentication methods. This is their email address, this is their phone number. So there is some PII, but I mean, the rest is PII as well. Also their preference you get from the Graph API, so you can see what the preferred authentication method is. And then in this case, SMS is not allowed, so it's only phone recipient. So basically you get a phone call from Azure, it's like, hey, are you this? And then you confirm. But you can also use the email address. So in this case, some Russian email address was added to it. And that user can use the same password and use the email address as the second factor to actually get stuff done. And one of the things we can now do as well, since we know these relationships, we can also see what other shared MFA settings are there, because sometimes there's account sharing, sometimes there's account hijacking, sometimes it's both. So we can actually start building some detections based on this, where we assume it's not relevant. So this is from a real environment, that's why it's so tiny and you probably can't even see it. But there's like all kinds of small clusters here of shared accounts or accounts with shared MFA settings. And a slightly bigger one is this example, which is for me illegible. Sorry about that, but it's probably the beamer. Blame it on tech. There's two really big pockets there, and that's one of the things I learned is that a lot of teams, or at least at a couple of clients, teams that build accounts for new hires, whatever, they use a placeholder phone number because they need to assign one MFA factor on creation. That's just the Azure policy that they have. You need to have MFA. So even if you create a new account, it needs to have an MFA property already. Apparently that's a technical thing. I wasn't aware of that. But these can be filtered out quite easily. And for some reason, it looks like a Ninja Turtle to me. But this is also a real example from one of those clients, is where the user that is very blurred is a finance executive. And why the hell does a finance executive need to share their phone number with 4 other accounts? So this actually was a compromised user. So that's why I added it and heavily blurred it. But their phone number was sort of not their phone number. But that not their phone number was also not one of the phone numbers of one of those other ones. So it's basically hijacked accounts where they chained it to actually try to steal money, which they fortunately didn't. But still, it was interesting. And there were no other alerts around those accounts. So still, that was pretty cool compromise. In terms of implementation, I would recommend, you still need SharpHound and AzureHound, because from the original source, you get way more information than logs. Logs are nice, but they're very limited in some fashions as well. So you still want to get all that information. And with SharpHound, you can use LDAP filters to only do updates, right? So you can get smaller sets. I'm not aware of that Azure can do that, AzureHound. I don't think so. Would be nice, because some of those sets are humongous. I see nods. Oh, cool. Okay, I need to know that. And then on top of that, you can schedule FalconHound in a period you like. I would recommend 15 minutes, unless your environment is that big that it can't cope with that, then set it to an hour, I don't care. But as frequent as you can, because you want to see that lateral movement stuff. So in terms of support, BHE is not supported yet, apart from sessions. I can do sessions, but in a less preferred way. And the primary reason is, this is an event log. If you've never seen it, it's pretty depressing. But they don't have the SID. And everything in BHE is SID-based, and also BHCE. So my workaround for CE is Neo4j, because I can directly access that and do anything I like, which is very nice. But BHE doesn't have that capability for all the right reasons, because they don't want you to fiddle with their database, since they have to support it. But the SID thing is a problem, because one of the things I tried first was every time I get a new session, for instance, for a user, I queried the API of BloodHound, got the SID, and then started doing the same for the computer and then updating it. That works. But if you have to do that for 5,000 sessions every 15 minutes, the API doesn't really like you as much as you might expect. So one of the things I now built in the meantime is on first run every day, I collect all the users and all the computers in a local SQLite database, and I use that as a reference point, because that's like 500 times quicker, but still not very preferable, right? Because we're storing all kinds of information that we already have, so it's not very efficient. So that's something I know that the team is aware of and working on, so that's going to be supported probably soon, hopefully. But at least they're working on it, so that's great. Yeah, and why would you consider it if the examples weren't clear enough? I mean, you would have up-to-date sessions, all kinds of path MFA settings, alerts, vulnerability information. So the use case is broader than only your identity team or only the SOC. I think you can apply it in multiple ways. And especially the unexpected account sharing, I haven't found a better way of doing it. I also built some normal SIM logic for it, but it also relies on a time frame of data. So if the old hijack was 2 weeks ago, that's sort of usually outside of your lookback scope, because that's very, very costly to run. So having a database that actually can be queried for that kind of stuff is very relevant. And the coolest bit is that you can like continuously evaluate all the attack paths in your environment and actually see it grow and shrink, hopefully shrink. Yeah, and the rest is I think it's the same. So also the IR team would love this, because they can also see, they can basically trace back also how a user went through the attack or to the flows. So yeah, I kind of modified this thing, right? This is still the same, regardless if it's true or not. But defenders can now also leverage these graphs to make more lists. And as long as this is true, attackers won't be able to win, hopefully. So with that, tools available. It's open source. It's free. It will remain to be free. Hopefully you use it. Hopefully you give me either feedback that it sucks, or do a pull request with some awesome new queries. And with that, I leave it to questions. Thank you. Oh yeah, and while flying over here with that nice white line, it actually also works on the airplane Wi-Fi. It's slow, but it doesn't fail doing hundreds of API calls. Yes?
You mentioned that the BloodHound API stuff is under development. The GitHub page says early release. Well, what are the specific limitations?
Yeah, well, the primary limitation is that everything needs to have a SID or object ID in Neo4j language, which is not always available in the data that I want to ship towards it. So I have to have either a lookup reference or a more forgiving cipher. So you can do cipher over the BloodHound API, but I can't do sets, I can't do merges, and some other things that I like to do. That's one of the reasons. The other reason is that the whole team has built it with a certain use case, right? So they built a model and a schema that is hard-coded into the code so that they can validate all the data that comes in. Is this what I expect? No, then I ignore it. And all that stuff that I showed you with additional edges and properties isn't in that model. So it won't accept it stock. So those are the primary reasons for now why I stopped developing it, because it's sort of, I'm banging my head against a virtual wall which doesn't give. So there's two options. I am talking to the team and they are aware of most of it. So they're working on a way to support it, which is awesome. So in the meantime, Neo4j is still supported as long as it is. So we can just use that for the open source version. For the closed source version, yeah, then we have to wait for these functionalities.
Any idea how long it might be until?
No, I don't work for SpecterOps, so I have no influence over this at all. I can just make suggestions what I would like to see, and that isn't a guarantee that it will come, because it's their product, and I can only...
I'm just wondering how receptive they...
Very. Yeah, very, but they have their own backlog, their own time frames, which I can't dictate, and I'm happy about that as well. Yeah, no, but it's very easy to talk to them and give them suggestions, and everybody can, since it's also partially open source, everybody can make a Git issue, make a recommendation, and will be seriously treated. So.
I noticed for the graph visualization, you use the native Neo4j and it looks like BloodHound.
Yeah, yeah, I dark mode BloodHound because I didn't like the white thing.
Are there other software packages or things that are good for graph visualizations?
That work directly with Neo4j, I wouldn't really know. There's billions of them, but most of them you need to. The good thing about the BloodHound UI is that it's tailored to the data set it's expecting, so it can give you all these fancier tables and these kinds of things. So if you can work with that, I would still recommend that. The only thing I ran into on large-scale environments is where the BloodHound UI has a different timeout than the Neo4j native interface. So if you have a query that takes too long to process, you'll get an error on the BloodHound interface, which the Neo4j instance won't. Just it looks ugly and it's annoying with all the bumpy thingies. I haven't looked further for other stuff. I usually just use the API and work with JSON because it's quicker. Not helpful, sorry, yeah.
Where are you pulling sessions from? Is that from Sentinel or from MDE?
Both.
And then,
So everything that shows me a session, I'll use. So in the repo, everything is enabled. So I wouldn't recommend doing that because why duplicating your effort? But yeah, so I don't have CrowdStrike API access yet because they don't like companies that also do red teams. But yeah, as soon as I get an API for that, they probably also store a local logon and maybe some other stuff. So I'll pull it from anywhere I can.
do you find that a lot of your clients are logging
Yeah,
4624s
yeah.
in Sentinel?
I haven't seen one that didn't. At least from the DC, right? Not from every local machine. So you'll have some limitations in terms of local logons you won't see via Sentinel. That's why I also have the Defender one. If you have Defender, go for that one. Because the cool thing about Defender, I had to skip that slide due to time constraints, but Defender, apart from the device logon events, as they call it, so that's basically 4624, but then in Defender, they also have a device information table where they store all the currently logged on users. So if it's not in there, you can already time it out and these kinds of things. So it's actually more capable because it will show you way more. Yes?
Are you using the Security Center API for everything in Defender, or are you actually having to go and do like live response queries, or like, I'm curious if there's anything that you're actually having to query the device itself, and it
No.
takes a while to like run an investigation package or anything like that?
Oh, no, I haven't needed that yet. But at some point, it's actually a cool idea to get some additional stuff that you can't get from other information sources. Generally, I just use the log analytics SDK or the Defender. They now call it M365D or whatever it's going to be tomorrow since the MVP summit is going on. So, yeah, I just use the native APIs that they give us that are fully supported, which is for long terms best. Yes.
Your suggestion in the slide was to run SharpHound and AzureHound infrequently and not collect session data. If you're already running them daily and collecting the session data,
Perfect.
does the session update that this does play nice with the data
Yeah.
that's already there?
Yeah. It will only update stuff that is older.
So the timeout, if you have a timeout set for 3 days and it checks after the 3rd day and the same session's still live, it won't time it out? Or?
No, because probably it's likely that there's still activity. So if there's activity, that timer will be updated every FalconHound run. So it's happy about that. It will, and if you're worried that you might still have some stuff that it times out, then you just disable that action to time it out. It's also an option. And it also depends on how you're doing your path calculation. So if you have all your relationships in your query that you are caring about, so like the hash session, then you either have to add the head session, or depending on the environment, how big it is and how efficient, you can also just remove all the relations and have it look at everything. But that might be performance intensive, so I wouldn't necessarily recommend that. But there's a fix for both sides. Cool. Thanks for all the questions.